we got as 0, 1.4 is the observed value, and this complete value is predicted value. So what is the error we are getting? 3.1. That means if I suppose if we try to plot a curve, y-axis equal to sum of square of errors, and x value is the intercept value. Okay, intercept value. If I take 0 value as intercept, what is the sum of squares error we are getting? 3.1. So what is the ultimate aim? Which line is better? Which is the line I need to choose? With minimum error. That means with minimum SSC. So I need to select. I keep on changing the values so that I can plot the. I can keep on plotting the this one SSC values. At the point at which the SSC values minimum, I need to consider that particular x-axis value as a optimal intercept value. So see here. So what we are doing, when we choose intercept equal to 0, okay, so we are plotting a curve here. Okay, so when we choose 0, so we are plotting a value, and then so what we are doing is changing the intercept from 0 and move towards x direction. We are plotting various SSR values, and the value at which the curve is minimum, we are choosing that particular intercept value. So how to choose that? Okay, so here when we intercept equal to 0, okay, so we are plotting the value at 3 point the value is 3.1. Okay, now which direction we have to move? Next direction. So that is most important. Whether I need to move towards the left, towards the right, which direction? So that direction will be given by the gradient descent. So what is the gradient here? How we come to know that? See here we have second point. Okay, so how we come to know that? We move towards the lower part of the intercept in the x-axis. So for that we need to draw a tangent to the line. Okay, so SSR, we plotted the first point, and when we draw a line, a tangent to that particular line, okay, so the tangent is the gradient. Okay, so if based upon the direction of that particular tangent line, it indicates the direction we move to select the next x value. That is called gradient descent. So if we try to plot various points, okay, so various tangent lines to that particular curve, we will come to the various points. So first point is at 3.1. Then what is the next point? So at that particular point, try to draw a tangent curve. So tangent curve is towards the lower bottom. That means right side. So we have to move towards right side. Initially we are at 0. And the first line, the first blue line indicates that the gradient is towards the bottom and the right bottom. So we have to move from 0 to towards that particular blue point. So after 0, we can select some other point between 1, 0 and 1. Okay, so next value we will choose. So like that we keep on moving, and finally we will reach the minimum point. But between 0 and 1 also we have multiple set of values. Not only between initial values, between 0 and 1 also we have infinite set of values. So between 0 and 1, which is the best set of value? Again, whenever there are a set of values, we need to select the best set of value. So here we have some mathematical calculations we need to do. So before computing the construct. The mouse is not working.
What about this mouse?
I just removed it. Actually, we're using this mouse only.
Or that is connecting?
I know. No, we keep this only. But I don't know why it got.
Okay.
Okay, 1 second. Check. Visible. Where he went? So any doubts? In gradient descent? So we can use this gradient descent to find out any unknowns with a condition that the unknowns should be the optimal set of values. That's it. It should not be any random set of values. So there is an equation. That equation is y equal to mx plus c, and I need to find out weight and intercept. Condition is with those weight and intercept, my SSR value should be minimum. That's it. So here, the what is SSR? SSR equal to residual, which is equal to original value minus predicted value. So predicted value means my equation. My equation contains y equal to mx plus c. In that, I am assuming that 0.64 is fixed, and I'm trying to print the find out the intercept. This intercept should be optimal value. Okay, so that is the problem. So what we are doing, I am starting with 0. Okay, so I can do it 3.1, next 0.1, 0.2 I can proceed, but that is not optimal way to, because number of iterations may increase to converge the problem. So what we are doing is we are taking the help of gradient descent. So what is gradient descent? Start with some initial set of value, find out the SSR. Okay, this 0 value will be the intercept value. So intercept value I will substitute, because I have 3 points. 3 points here with intercept equal to 0, I will get this is the value, and I will get the error. Once I get the error, so what I will plot the value 0, 3.1. Now what is the direction? So I need to draw a curve like this. This says that from 0 to catch this line, I need to move towards this direction. So next value, but next value again there are infinite set of values. What will be my next value? So that next value, how I can find out is with the help of two things. One is my derivative and one is learning rate. So how to find out the derivative? What derivative will tell us? Derivative tell us what is a small change in intercept and the impact on the SSR. That is what derivative. What is that impact? That impact is based upon a formula we need to compute. What is that formula we computed? The formula is this one, by using the impact of SSR, intercept on SSR. What is the formula? This is the formula we computed. Okay, this is the formula. This is the impact. Based upon the impact, we can compute the gradient. Once we compute the gradient, that means impact means if I substitute on all the 3 points, I will get the gradient value. What is that gradient value? They put it here. This here, derivative value, this one. And once I get the derivative value, I need to work on the learning rate. So learning rate means how much I can jump. Okay, so minus 5.7 into 0.1. This is also hyperparameter which we can fix. So minus indicates towards right direction. Plus indicates I need to move towards left direction. Why? Because already minus is present. So this minus is this minus. So minus into minus become plus. So here if it is minus plus, so positive direction. I need to add 0 plus something. So positive direction. Here if I get positive value, already minus is there. 0 minus something, I need to move towards left direction. So which direction and how much will be given by the step size. That is for one value. Similarly, we need to find out m value also. This is for intercept, this is for m. Again, we need to frame an equation. By framing the equation, we need to compute this one. This is the impact. This is the impact on the intercept. Same again. There we start with only single value. Here we start with 2 set of values, and we substitute here for intercept, and here we substitute for slope. Now if you see here in the earlier formula, once if we fix the 0.64, the value, this one, the impact value is what we got here. See here there is no slope, because slope we already fixed. Okay, so only intercept we need to consider. But when we are working on both intercept and slope, see the formula here is both intercept slope. So intercept is impacting SSR, then there is a role of slope also. When we want to find out the impact of slope on SSR, there is an intercept also, because this is not a we are not fixing a slope value, right? So these are the 2 equations we need to consider for 2 unknowns and try to solve the problem. So with this, we are moving towards very simple topic, decision trees. So what is decision tree? As we have seen, there will be a root node, and these are all the interior nodes. These are all the leaf nodes. So what is a root node? Root node is the initial node which represents the entire sample. That means entire set of features we will consider. So based upon the features, this is a row. Okay, based upon the feature, we suppose we can features, the root nodes will be filled with the feature values, and these leaf nodes are filled with the label values. Okay, so features and labels. So based upon the feature, we move towards root to interior, interior to decision node or the leaf node. Okay, suppose salary is between this range, yes, no, then again yes, no, then again yes, no, then only this one. This is a class. How many classes are there? Class, this is one class, this is two. So we have two class problem, right? One is declined offer, another one is accept offer. Two classes. Two class decision we need to take with the help of some set of values. So salary is one feature, then near is one feature, then provides cab is one feature. So we need to select the order of which features I can start. I can start with salary, or salary near provides, or provide salary near. So how to start? Because see, there are three features. Each row, based upon the tree, what I can compute is there are three features. One is salary, and second one is nearness, and third one is providing the cab. Okay, so these are all the values. Okay, now the class value, class is there, that is the fourth column, accept or non-accept. So here also we have some set of values. Okay, so now with these values, with this data and labels, it has to compute the tree. Once we compute the decision tree, if I give any test value or any unknown value, it will give me the option of the accepting or rejecting the offer. So now we have three labels, three features. Why salary is here? Why not salary is here? Why office is here? Why not office is here? So why provides is here? Why not provides is here? So again, there exists a mathematical formula of forming the order of features. Okay, so see here. So loves soda, yes, no. Okay, age less than 12.5, yes, no. Then if it is yes, does not love Troll 2. Troll 2 is a movie. No, loves Troll 2, does not love Troll 2. So two class problem with two features, right? Like that, this is how a decision tree works. Now we'll look into one example. So what is the example here? There are three features: loves popcorn, loves soda, age. And what is the label here that we need to predict? That is loves Troll 2. Say Troll 2 is a movie, so loves Troll 2. Okay, these are the set of features. Now with this data, okay, so we can build a classifiers we have seen. Okay, now we can build a decision tree. So how to build a decision tree based upon this particular value? See here. So this is how tree starts. I need to select one of the feature, right? Based upon the features, the root node, the interior nodes are the features, and the leaves are the labels. Okay, so now which feature I need to select? I need to select loves popcorn or loves soda or age. Which one I need to select? Now assume that I started with loves popcorn. This is loves popcorn. Now see, loves popcorn, this is label. Trolls love to. See, what are the possible values for loves popcorn? Yes, no. So yes, no. Next, loves troll 2. Again, loves troll 2, how many values are there? Yes, no. Yes, no. Now, if I choose loves popcorn and if I select yes, what happens? This is 1, this is 2, this is 3, 4. Yes results into no. Next, yes results into no. Okay, yes results into yes, and yes results into no. See here. See here. Finally, if loves popcorn is chosen, first column, if I choose yes, yes means 1, 2, 3, 4. How many yes and how many no are there? Yes, no 1, yes, no 2, yes, no 3. So that 3 equal to this 3. And if I choose yes, how many yes are there? Only 1. This 1 equal to this one. Okay. Next, Now, if I choose no, okay, if I choose no, what happens? No, yes, 1, no, yes, 2, no, no, 1. So, no, no, 1, okay, this no, no, 1 equal to this. And how many no, yes are there? 2. This is how tree works. Next tree. The problem is ultimately when I the label, when I reach the label, it has to say either yes or no. Suppose if I choose loves popcorn, yes. So loves popcorn, yes. What happens? I cannot take a decision because it is not pure. That means there is a confusion. If I reach here, the leaf contains both yes and no. So I cannot say the decision. Similarly, if I comes no, then both contains the value yes and no. So here also I cannot take a decision. So this will be a cancel out. Now, as first feature doesn't work, loves popcorn, let's check the loves soda. Same technique if we follow, what happens? See here, loves soda, then if it is yes, there are 3 yes and 1 no. If I choose no, then what happens? There is no yes and all no's. So this is, if loves soda is no, then there is a clear cut decision that he is not liking the no. Okay, here there is no problem, but here 3 yes are there, 1 no is there. So here again there is a problem. So if the label contains one or more class, we are calling it as a impure. Okay, now see, without plotting this, what we are doing is we are computing a formula. That formula is called as Gini impurity. So what we are doing, we are loves popcorn. Loves popcorn is also having both the classes. Okay, and loves soda also having both the classes. Now both are impure. This case is also impure, and this case is also impure. Now we need to compute which is the best impure, worst impure. Impure means it should be less. Okay, so mathematically, how we can compute with the help of Gini impurity? What is Gini impurity? 1 minus the probability of yes whole square minus the probability of no whole square. So 1 minus, suppose if you want to compute for loves popcorn. So 1 minus the number of yes. How many yes are there? 1. So this 1 equal to this 1 by 1 plus 3 whole square minus here. Okay. The number of no. What is number of no? 3. 3 by 1 plus 3 whole square. The impurity of this particular node is 0.375. Okay. Now this is 0.375. For this node also, 1 minus yes 2 by 2 plus 1 whole square minus 1 by 2 plus 1 whole square, which is equal to 0.44. Which is more impure? Second one. This one is more impure. This is somewhat okay. Now go to this one. Now go to, okay, this is also same. We got the values 0.375, 0.44. Okay. Now see loves soda. If I compute for loves soda, what is the impurity values? 0.214. Okay, same. Here there is no need of impure. Here there is no need to compute the impure. Why? Because S is 0. Directly I can take a decision. So by applying the Gini formula, if I compute the values, okay. So for in this case, it is equal to 0.415. What are those two values? Here, loves popcorn 0.375, 0.444, and this one loves soda 0.214. Only one node is without any impurity. Now what to do? If I follow this decision, both I struck. If I follow this feature, here I struck, but this is fine. So now what I have to do? If I see, if I choose this feature, I am stuck in here. So this is okay. Now if this feature is having a problem, then I can consider another two features. That is this one or EH. But this one is also having highest impurity. So here I cannot replace this one. I cannot to solve this problem. I cannot use loves popcorn. So ultimate one is I have to use age. So age is the next feature I'm using so that I can solve this particular complexity or confusion. So what we need to do is, so age I have taken, loves troll 2. Now what is the difference between, what is the average of these two? 19 by 2, 9.5. 12 plus 18, 30 by 2, 15. 35, 38, this one. So like that, I need to compute the average of adjacent values. Okay. So if I compute the average of adjacent values, so these are the values and this is the label. So here what I'm doing is so love soda, this particular case no issue, nothing to touch. So I need to solve this particular problem. So I want to replace this particular node with age. So now see, you loves popcorn, no issues, because already it is a high impure. Okay, now see, is it possible to use age less than age 1? Okay, so age I can choose. So love soda, no, doesn't have any problem, I can proceed. So love soda, now I am taking help of age. Okay, so age. So now what I can do is I can choose the values. So now assume that I have selected age less than 12.5. Now if you see, based upon the age 1, okay, if I select 7, only one case no. If I select these cases, all yes. So which is the best age I can choose? Say the condition is which is greater than this and which is less than this will help me to come up to split the age value, right? Why? Because age is 7, only one case no. Two parts without any impurity. So I am selecting here 12 is there, so I am selecting 12.5. So if I select 12.5, what happens? So love stroll 12.5, less than that only no. Okay, so no is 1 and yes equal to 0. Now 12.5 and above, all are yes, 3 are yes, these 3 are yes, and no, there is no 0. Okay, so love soda with, if it is age less than 12.5, these are the nodes I am getting, and original node is this one, it is already there. Okay, suppose if it is not age, if I use loves popcorn, this feature is ending up with again impurity. Okay, so what happens is I'm choosing love soda instead of love popcorn. Why? Because it is tracking, it is not giving me the direct label. Okay, so I'm choosing love soda, then there is no problem if I choose no. If I choose yes, then there is a problem, and for that problem I replace love soda with age. So this is how I computed now. And if at all any value, if it goes this direction, love troll equal to no. If it goes this direction, love troll equal to yes. If this goes this direction, love troll equal to no. So that's what we are replacing here. So this is the decision tree we are able to find out with the help of the data. Once we compute the decision tree, any unseen case, like say yes, yes, 37. What is the value? Yes, yes, 37. Yes, yes. Okay. Okay, if it is 1 yes, I will come here. 37. 37 means it is not less than 25, it is greater. Okay, it is no. Okay, love trolls to no, he doesn't trolls the love troll. Okay, so here this doesn't have any impact, only these two rows can help me to solve the problem. Okay, so that's why what we are doing in decision tree, randomly we are selecting one particular column we are selecting, and we are dividing the label. The label means the target class. If we end up with any of the label as 0, then that is pure. If we have both the values, that is impure. It doesn't help us. So what we need to do, this case we need to replace with any next feature. Okay, see here, if both are impure, then we cannot do anything, we have to stop with that. If only one thing, then what we can do, we can replace with another feature, right? So we already looked into this feature, which is not helping, so I'm going to next feature, which is age. So based upon age, if I select an exact value, that will help me to split into two types, that is 12.5. So if I select 12.5, based upon this, I can easily classify. So this is how decision tree works. So decision tree, to build decision tree, we need, the formula is Gini impurity. So based upon Gini impurity, we can build our own decision trees. Okay. So any doubt here in decision trees? Can someone summarize what are the steps involved in decision trees? So what are steps? What is a internal node? Interior node is a either it's a label or a label or a feature. Internal node feature. Okay, so the label is the leaves are the labels. The ultimate aim is when I reach the label, there should not be any confusion to select the class label. So in that way, we have to choose the order of features. So who will help us? Gini impurity will help us. Whether I can select the which feature, which order. So randomly we start with any of the feature, and based upon the Gini value, either I can proceed yes or no. If both the yes and no, if I struck, then I need to opt for the second feature. Okay. So this is how we do the classification, uh, mandatory classification. So we transform the data into a. This is how. This is what the data we have. This is the data given, and we learned a decision tree. Okay, and then any unknown case we can give the classification label. Okay, so this is called as learning. So we can able to transform the tree into a decision tree. So now we move into the regression tree. So what is regression tree? What is output in regression tree? So in case of classification, it will give the label, class label. It will give. Okay, so it will give us the either no or yes. And in case of regression, it has to give the value. Okay, so what we in regression tree, what we will do is same. We have to build from root, and we need to check out. So what we are going to do is, say we have data, we have say drug dose. Okay, drug dose, whatever maybe, we have some set of values plotted here, and we have some y axis with some set of values. So based upon this, we need to find out if I give any new point, what is ultimate aim. If I give any new point, I need to find get the effectiveness. If I give any point here, I need to get the effectiveness. So that is ultimate aim. So these 2 points are unknown points that I need to generalize, and these points are the train data or the existing points. So how to learn the regression tree? So see here, if the curve, see, forget about all other curves. Okay, so first I am selecting first two curves, 2 points here, and I'm these are another set, these are another set. Okay, so we need to select a point where it can equally distribute the points. So now I start with first 2 points. Okay, so if I start with first 2 points, this one. Now if I what are the two values here? First two values, if I select the, if dose is less than 3, so 1 2 3, this is a point. Okay, less than 3, and the number of points above 3. Okay, if the number, if the average means the dose value is less than 3, what is the average value? 0. Why? Because it is close to 0. And the number of points, what are the number of points? These are the points, these are all the points. For all these points, compute the drug value, this drug effectiveness value, and compute the average. So what is the average? We get 30.8. So for this is the value, for this is the value. Like this, we have to get the set of values for all these points, and we need to compute the average. Right side, left side. So left side only 1 point here we have, which is equal to 0. And for all these points, if I compute the y value and take the average, which is equal to 38.8. Right, now you see here, this is 0. Now here if you see, 38.8 is the average effectiveness, but for some points, see, for some points the effectiveness is close to 100. Now see, if I put any value, what happens? It adjusts between either 0 or 38.8. But if you see here, many of the points are here whose value is close to 100, whose value is close to 75. Okay, so if I split like this, then I we take the average of these, all the effectiveness values, the value equal to 38.8. But that means any value, some anywhere, suppose if I move towards this direction, and if I put a point, suppose ground truth is this point. So ground truth value, what is that? 51. But according to this tree, what happens? 38.8. Yes or no? If my dose, all the points beyond this direction, above 3, it is averaging it to 38.8. But in majority of cases, so all these cases, okay, it is beyond 38. So this option is not correct. This split is not correct. So those less than 3, even though left side is correct, but right side, all these cases, okay. So these set of cases are ending up with erroneous data. So this is 100, 100, 100, 100. But according to this particular rule, suppose my point is here, its effectiveness is 80, but it is classifying as a 38.8. So now what I need to do, I just move the line towards right. Okay, so this is all the points. See, this is the point. For dose greater than 3, okay, 100% effectiveness are there according to data, but according to decision tree, it is 38.8. So data is 100, 38.8 according to decision tree. So this decision tree is not reflecting the points here. Okay, so what we are now, if that is the case, we are computing the error. Okay, see here. Suppose this is the point, right? So what we are doing, any point here 2 points, how many points we have? 2 points. Okay, and here we have number of points. So one is 0, another one is 0. Okay, see, these are all 0 points. Then we have 5, 20, 100, like that we have some set of points. Okay, so these 3 points we have, these 4 points we have. Next, all other is varying from, see, these are all the values. Now if we say like this, the average equal to 0, average 38.8, what is happening? If we compute the distance, the error is 27 comma 468.5. The error is 27 thousands comma 468 is the error. If you find out the difference between the original value, original drug effectiveness, and predicted, because on an average we are telling that 38, for all the points beyond from the third point to all the points, it is 38 only. But few of the points have 100 effectiveness, see, for 100 effectiveness, but you are telling that it is 38.8 as the average. Okay, so for these 2 points it's fine, but for these points, making the average 38.8 is erroneous. It is this much error. So what is the next step involves? Next step involves is we are moving. Now we shift the dose threshold to be the average of the second and third measurements. So now what we are doing, earlier we have taken 1 and 2. Now we are taking 2 and 3. So 2 and 3 we are taking, and see, remaining all are this side. 2 and 3 are this side. Okay, and for 2 and 3, if we take the average, what is average? 41.1, right? Okay, so for these points, if we take the average of drug effectiveness, it is 41.1, whereas the average of 2 and 3 equal to 0. Now again you compute by keeping the curve at 41.1, you compute the distance or the error. This is the error. The line, any line is a set of predicted values. These are original values. What is the error? If we compute like this, we may end up with computing some set of values. Okay, so what we need to do, if I compute, okay, so we need to compute the error, that means SSR, and the average value. So if I consider dose 3, what is my error? 27,000. So if I compute dose 3, the error is 27,000, somewhere here. Okay, somewhere here. Next, if I consider my dose as 5, somewhere here. So like that, you keep on moving the curve towards this direction, and you have to split the tree towards left, towards right, and compute the average of drug effectiveness and of these people, and average of drug effectiveness of these people, and fit the curve, compute the distance, and plot the error value. The point at which the drug value which gives us the minimum SSR, we are calling it as a best SSR. So that value, see, first we start with less than 3, then less than 5 points, less than 7 points. Like that, we keep on moving and we keep on plotting the curve. At some drug dose, if we consider somewhere it will reach minimum point, that will be my split value. If we split based upon that particular value, we may get yes or we may get no. So based upon this, we can predict the value. So like this, we have to do many iterations like this and keep on moving. At some point of time, this will be my minimum value. See, why we didn't stop with minimum value? Why again we have computing. See, if we have to move this direction, then again it may increase. So after plotting certain values, we feel that this is the best. So this drug value is maybe 17. So drug value 17 is the best, which will return split the tree into two types, left and right, so that I can assign the effectiveness. So ultimately I end up with 14 point something close to this one, 14.5 or something closely. I will move like this. I keep on moving this average, this side average. So somewhere I will end up finally with 14.5 average. Then again splitting the curve. Okay, so 14.5. Then again we keep on moving this direction, this direction. So this is how we end up with average 1 and average 20. And last somewhere same, we are splitting. Somewhere we end up with this particular case. 100% effective. See, for this case greater than 23.36, 23.6 means this one, 23.6 here somewhere. For all these points, effectiveness is equal to 100. So finally what happens, this table and this decision tree must be in sync. Okay, so this plot and this decision tree must be in sync. So like that we have to. So if it is greater, suppose if it is 22, okay, suppose 22, okay, 22 is this point. What is effectiveness? 100. Okay, now if you see it is 22, less than 14.5, no, comes here. Greater than or equal to 29, no. Greater than or equal to 23.5, okay, 22, okay. So when I say 23, 24, no, beyond this, okay, 100% effective. So like this, you keep on moving the curve and adjust the values. Finally, these data points and this tree must be in sync. So these are the regression values. Is it clear? So ultimately what we have to do is, so you have to keep on moving from one tree, and then if it unable to split it, so here we have what is happening. See, till here we have to take one value, till here we have to take one value, and for this combination we have to take one value, for this combination we have to take one value. So these are all the split values we have to consider in the tree. Okay, so this is how we keep on moving from like this average 50 average. So we can keep on moving with various set of values. So this is decision tree, how we work with regression, and this is the classification tree. This is the classification tree. Based upon the Gini index, we can compute the class label. Okay, any doubts here? From offline participants, any doubt? So again, what is mathematics here? In